program. Alternative fuel vehicles. So not just thinking about mass transportation, that's not available to everybody in every location. We're lucky here in Portland, Oregon. But alternative fuel vehicles are also very important. So we're talking about hydrogen, ethanol, hybrid vehicles, but maybe run by biomass, biofuels. But there needs to be some measure of how efficient these are, and that's what these are. So they have to be classified either as a zero emission vehicle, ZEV, or have a green score of at least 40 or more by ASEE, American Council of Energy Efficient Economy. And by the way, that was a refueling station for electric car outside of the Hawthorne Fred Meyers you saw an image of. So we're preparing for these changes. It takes the infrastructure. We have to lay down the framework for some of these big changes to be possible. So it's good to see it emerging. So sustainable sites, alternative transportation. This is an example where there's multiple credits associated with one concept. So sustainable sites, credits 4.1 through 4.4 are independent credits, but they all have to do with alternative transportation in different ways. There's a credit that has to deal with mass transportation, bicycle parking, having racks available for people to bike, but not just the racks. If you're going to work and you're all sweaty, that may not be appropriate for your profession. Maybe it's okay, maybe it's not. So have a shower facility within the building for people that are working there or using that space. If they live there, they're assumed to have their own showers, but if not, you're thinking about the showers in addition to having covered racks, a safe place for people to store their bikes. And the goal of it, once again, intent is very important, create a transit-oriented development, TOD, reduce pollution from auto use, and reduce land development from auto use. So not only are you reducing the CO2 emissions of the reduced amount of people individually driving to places, but also you're reducing the amount of parking area you need, the asphalt pavement that's impervious and has problems with heat island effect and stormwater we'll take a look at. So it's multiple effects. You also have to look at not just one element, but there's many sides to all of these strategies and things we're going to talk about. Vehicle miles traveled, a metric you can use, VMT. It's the measure of transportation demand that estimates miles associated with the project. So if you have a carpool program, you have parking spaces that are available for electric vehicles for a certain % of your building, then you're reducing the vehicle miles traveled that are associated with your project. You're taking that initiative. Here's an example. Much more heavily weighted in 2009 is alternative transportation, public transportation. So it's basically encouraging take advantage of these amenities if they're in your area. So really in Portland, we don't have much of an excuse to choose a site that is pretty close to one of these things. So 6 points for new construction, 4 points from schools, 6 points for core and shell. But here's what we're really talking about today. So 6 points. Do you guys remember how much it was to get certified in LEED 2009 rating system? 40? Yes. So 6 points is a lot for one credit. And this is just to locate your building within half a mile of a commuter rail or subway, or within a quarter of a mile of 2 bus lines. You could locate your site there. When you're going through your eco-charrette and you have your scorecard out, you go, low-hanging fruit, this is easy for us. 6 points, we're within a half mile of the max line if you're in Portland. This is something you want to be able to identify early on in a project to know your opportunities. When you're setting these targets for LEED certification or sustainability, you would want to know that this is something that's important in the new rating system. So there are many incentives and other inclinations to get certain certifications, in addition to just the good responsibility and showing that you took these initiatives. So it's an example of within the same sustainable sites, credit 4 family, but it's 4.3, and here we're talking about low emitting and fuel efficient vehicles, like we looked at in that past slide, 3 points for new construction, so still pretty heavily weighted. That's why it's in orange. So that's providing preferred parking for low emission vehicles. It's the same for 5% of the total parking for one option. Option 2, provide a charging station to refuel those electric cars or whatever alternative vehicle it is for 3% of the total parking spaces. So once again, you have options in many of these credits and how you achieve it. So we're talking about 3% of the parking, or maybe it's 3% of the full-time equivalent occupant. This is another measurement that LEED uses for calculations. So that is really what's useful about LEED, is we are actually using a metric, something that is universal for understanding this LEED rating system or green building rating system that evaluates how sustainable a building is. So full-time equivalent occupant, you have to understand how many people are actually using the building. So you're not just counting people, because some people are going to be in there part-time. Whether maybe you work half-time, or you're in a retail space where there's transient occupants that are coming in and out. So how do you calculate it? So a full-time equivalent occupant would be somebody that's in a building 40 hours a week. Then their FTE value is 1. This is an important concept that runs through many credits within LEED rating system if you're doing calculations. Part-time or overtime occupant, you take the hours per week divided by 40. So if you're 20 hours per week, if you work half-time, your FTE value is what? 0.5. Thank you. So not scary math here, but just something you have to be able to evaluate. So occupant hours per week divided by 40. Site development. Once again, it has 2 credits related to it, but the intent is the most important part. Conserve existing natural areas, restore damaged areas, provide habitat space, and promote biodiversity. So biodiversity is that natural variation in the ecology and how these systems work that we really can't recreate. So when we cut down a bunch of trees and we replant one type, whatever we decide, we're not recreating what was already there. We have to be cognizant of what's native in that area and what actually is going to survive there. So wetlands can count towards open space in the LEED rating system, but now if it's a big crater or something we've created, it can have more of a slope of 1 to 4 on its sides. But here's a shot of Portland and how there's just kind of this wetland type area in the middle of a very vibrant community in the Pearl District. So this was just a choice that was made, I'm sure very early on, that we're going to preserve that land and let those natural ecosystems do their job, help us with stormwater management, lower our utility bills. Just let that site do what it's intended to do. Sensible. So you're mimicking natural hydrology. When we're talking about stormwater management, there are structural, man-made things we can do, and then there's more passive things where we can just try to mimic what the site would naturally want to do by itself, but because it can handle the rainwater that's coming down if we didn't have all this impervious surface on it that's causing all this runoff. So on-site infiltration, once again, this is where the LEED rating system is really aligning with code, and it's based on your state and local jurisdiction, but in Oregon, on-site infiltration is a huge priority and something that's pushed heavily in our codes and keeps getting more stringent and more stringent. So it's easier to have a LEED building in Portland because we're already pushing for this energy efficiency in our 2010 energy code. We're pushing for it in our stormwater management codes for building. So it's already aligning naturally with the LEED rating system. So if it's on-site infiltration, it's just naturally infiltrate on site. You have to check your soil, your permeability. Somebody has to test that, see how quickly the soil in your area can absorb. Clay might be a little harder. You know, it varies even within Portland what areas can infiltrate at what rate. I feel like a civil engineer might come out and do that or design these systems. But it's important for us to all be aware of why this is happening, why this is important. So naturally, pollutants are broken down by these microorganisms and by these chemical, biological, and physical processes that happen. So if you let it sit there for a long time, like a pond, a wet detention pond, then you give more time to this process to break down the chemicals. So by the time it gets absorbed, it goes back to the water table in our aquifers, it's treated. It doesn't have all these chemicals, like if it just shoots off of our roads, brings those contaminants or fertilizers right into our rivers that some people are swimming in and trying to enjoy. So here's a little example of what happens when we develop an area. So this is natural ground cover. We're looking at about 25% deep infiltration. This is really important to the potable water that we need to consume, that fresh water we need. It needs to be recharged. That's part of our ecosystem we depend on. And only 10% of it's runoff. Some of it might flow away. And then it's 40% of evapotranspiration. So that's what vegetation naturally does. It releases some of that back into the atmosphere. Here we've got impervious surface like 75 to 100%, and not that atypical for a developed area. And here we only have 5% of it going back into deep infiltration, recharging those aquifers. That's a problem. If we look long term, when we get in the water section, we'll see why this is such a problem and why we are going to see some changes in the next few years. 55% of it's runoff, so we're just shooting it away. In Portland, we could be using this for many resources. California would be envious many months of the rainwater we could collect and be reusing. Our codes are just catching up with that now and letting us actually use that rainwater for multiple sources we'll look at in the water section. Strategies. So once again, I said there's structural things you can do, non-structural things you can do. These are really pretty cost-effective things to do. Rain gardens can be a nice aesthetic to a building. Vegetative or bioswales, vegetated swales or bioswales, kind of interchangeable. Underground parking. So if you have underground parking, you have less asphalt covering the site, so you have more opportunities for impervious surface, vegetation, and that's also a synergy with a few other credits, open space, keeping nice vegetation, and also heat island, which we'll look at. Open grid paving, so that's that photo right here, just showing that if it's 25% vegetated, then you can call it open paving according to LEED. And it can count towards vegetated space for some credits. I think I can walk on high heels and still get around here. Porous pavement or permeable asphalt, there's a few variations of this. So it's allowing, now this could look pretty similar to your typical asphalt. It's allowing for water to infiltrate through that asphalt. And below that, this is just a diagram of having this uniformly graded stone. So it needs to be 40% void space to allow that water to keep coming through. And then in this case, since it might be heavy traffic, maybe a lot of discharge from cars and things, we may want to filter fabric before we let it go back into that deep infiltration layer. More strategies. Once again, looking at a new model of building maybe. You know, they don't have to all be boxes. We can think differently. Green roofs would be a way to handle stormwater management, give more open space, once again reduce heat island, synergies in the impacts and the benefits we get. Here's an example of a green wall. But this is an envelope of a building. And the close-up is to show water is actually funneling down from the roof and going into this collection area, feeding this green wall and possibly being reused for other resources. And this green wall can have many benefits depending on your climate. Maybe you want that shading to cool your building down. Many benefits can come from this, helping the air quality and so on. Best management practices. So once again, this is for our stormwater management. So this is really about treating the quality of the stormwater runoff before it leaves your site. So you're reducing the total suspended solids. So we talked about turbidity, those little particles that are too small to go down to the bottom of the stream or river because they're just hovering. So in that case, you would need some sort of filtration. And here's one example of how to do that. Rain Harvest Systems manufactures this infiltration filter. So it goes right in this manhole, and then it goes through several layers of filtration before it actually goes back to the main line. Detention ponds are example. Cisterns are for large collection of rainwater harvesting for reuse. And as for LEED purposes, a separation of a combined storm and sewer is encouraged. All right, sustainable sites credits 7.1 and 7.2, heat island effect. These last three families of credits we're talking about are very important because what we're really talking about here is synergy. If you start looking at these strategies, they're all working together. So heat island effect is what happens from dark, non-reflective surfaces, collecting that heat, we've all felt it, and then radiating it back up. All right, so we're looking at strategies for reducing heat island effect. But remember, these credits that we're talking about right now, the stormwater management, the maximizing open space, the heat island effect, these all have a lot of synergies and things that work together. So when we look at this strategy, minimize the development footprint, all of a sudden you have more room for either vegetation. This case right here is grass paved system. So this is actually drivable back to this garage. So it can infiltrate the stormwater. You don't have the asphalt, so you have reduced heat island effect, and you have more green space. Ideally, if this wasn't a grass paved system and it wasn't a driveway, we'd want native vegetation. That's what infiltrates stormwater the best. It's very important because grass doesn't really do the job. But in this case, a grass paved system hopefully has also laid a permeable surface underneath it that has good infiltration. So for heat island, provide shade from trees and structures, or something that LEED 2009 started to incorporate is it counts PV panels as well. So shading on a roof from PV panels is seen to be reducing heat island effect. There's an interesting synergy between green roofs and PVs. PVs don't function as well, many of the systems, the more heated up they get. So if you have a green roof underneath it, that can actually be weighting down the panel itself, helping with wind uplift and the structure you need, and be helping with its efficiency because it's cooling the temperature, the ambient temperature of where the PV is at on the roof, because of that evapotranspiration we saw in that diagram with stormwater management. Using hardscape materials and roofing with high reflectance. So SRI. Do you guys remember what that stands for? Yes, well done. Solar Reflectance Index. So that's what we're looking for when we're choosing our roofing material. You want high Solar Reflectance Index. And that also applies to on-site materials, so that's concrete. That's any number of paving systems. You can calculate that SRI value and help make that decision. And it can inform other decisions, like putting slag into your concrete often makes it lighter. So it's actually usually cheaper, recycled content, and you're reducing heat island. A lot of synergies with it. Or use open grid paving, 50% open, as we saw with vegetation in previous slide. So synergies with heat island. Green roof, review, stormwater, energy, open space, and heat island all get addressed by just implementing that one strategy. Recycle content. Look at slag in your concrete or fly ash. These both have recycled content in them and are good products you can incorporate into your concrete. So don't just look at SRI value. Think about what's actually going into these products themselves, depending on what type of system you're doing. Underground parking, synergy with open space, stormwater, and heat island. Light pollution. Minimize light trespass from the building and the site. So we saw when we looked at regional priority credits, this was important to Michigan. They made it one of their top 6 credits that are most important to a rural area in Michigan. So that's why they made that important for them, is to reduce sky glow. So you're increasing sky access, you're seeing stars. That's why we like to go camping or the mountains or somewhere, the beach, where we can actually enjoy that natural atmosphere. So you're improving nighttime visibility, glare reduction, safer for driving, reduce development impact on nocturnal environments. That's a big one, like in rural Michigan. And you want to look at this early on. So schematic design, you want to be looking about what type of exterior lighting fixtures you're choosing and how you're designing your site and integrating that into part of the process early on. If you have a lighting designer, that's fantastic, but if we're an educated team, we can all be working together on these ideas. Quotient Lighting has a lot of really interesting solutions. They were a part of the first Office of the Future, which is an interesting thing that's happening with the utilities down in Southern California. GluMac's new headquarters got this new Office of the Future certification, and they were using quotient lighting because quotient's really looking at real solutions. They're looking at holistically. Like this fixture right here is mounted to a desk, and it's helping with task lighting. So you don't have to have as bright of ambient lighting. So you can reduce that energy consumption. Once again, we have cost savings there. And it's not, you know, a big lamp that's sitting in the corner that you have to avoid when you're pushing papers around, because some people don't like that. That's why they don't like task lighting. So this is a nice little integrated system for task lighting with the luminaire right in there. And those are T5s, so they're more energy efficient. So the primary work zones have more flexibility and spaciousness.